Hello students, welcome back to the sixth video of this playlist. So in this video, we will be solving question number 6 from October 2024, the latest Mechanics 1 paper. So let's see what's the question number 6 from this paper is about. Okay, so this is question number 6. You can see on the screen. So basically, this question, the concepts behind this question, it's combinedly from chapter 4, which is the dynamics of a particle moving in a straight line, then chapter 5, forces and friction, and chapter number 7, that is statics of your mechanics 1 textbook. So let's get started with question number 6. Okay. So right at the beginning, you can see a figure 4. There is an inclined plane, okay, where a particle P lies, and you can see on the particle P there is a horizontal force H Newton is acting. Okay, fine. Let's see what they says. A particle P of mass 5 kg lies on the surface of a rough plane. That means the plane has irregular surfaces and it has friction. The plane is inclined at an angle alpha to the horizontal, where tan alpha equals to 3 over 4. The particle is held in equilibrium by a horizontal force of magnitude h newtons as shown in figure 4. That means the system is in equilibrium. That means the resultant force acting on particle P is 0 Newton. The horizontal force acts in a vertical plane containing a line of greatest slope of the inclined plane. The coefficient of friction between the particle and the plane is 1 over 4. The coefficient of friction is given. Okay, so part A is asking here to find the smallest possible value of h. We need to find out the smallest possible value of h. Okay, fine. We need to find out the smallest possible value of h. Okay, so here, since the system has friction, it is a rough inclined plane. So our main, the not the main, our first approach should be to find out the normal contact force, because friction is mu r. In order to find out the friction, we need what? The normal contact force. So let's aim at first to find out the normal contact force. Okay, so for part A, we will resolve the forces vertically along of the inclined plane. So what are the forces acting? R, right? The normal contact force, it acts perpendicular to the plane. Okay, so look, R, it acts what? Perpendicular to the plane. In this, okay, it's acting. Hold a bit. So R is acting in that way. This is R. The weight of the particle P is acting that way. I'm just resolving the force components, and this is weight, this is R, this is weight. Weight is how much? 5g. Okay, weight is 5g newtons. Okay, and the vertical component of weight is that one. Okay, so the angle between the vertical component and the resultant, that is weight, is what? Alpha. Okay, and normal contact force, sorry, the horizontal component parallel to the plane, this is that one. Okay, so we are resolving the forces perpendicular to the plane. So in the upward direction, r acts, and in the downward direction, the vertical component of weight acts, and also the vertical component of the h Newton. Okay, so this, if this is alpha, then this is also alpha. Fine. Okay, so what's the vertical component of the weight? This is what? Alpha. So the vertical component of weight would be what? 5g cos alpha, right? and the vertical component of h Newton, that would be what? H vert, that would be h sine alpha, since it's the opposite side, isn't it? Opposite side of alpha, and this is adjacent side of alpha, that's why cos, and since it is opposite side of alpha, that's why sine. Fine. Okay, so both of them are acting what? Perpendicularly downward of the inclined plane. That means upward is reaction normal contact force alone, so R equals to h sine alpha plus what? 5g cos alpha. So let's put the values. Sine alpha, 10 alpha is given as 3 over 4. 10 alpha is what? 3 over 4. Okay, so sine alpha would be what? Sine alpha would be opposite. 10 alpha is opposite side over the adjacent side, so opposite side is 3. So sine alpha is opposite side over the hypotenuse, so hypotenuse is 5, and cos alpha would be what? Adjacent side, which is 4, over the hypotenuse, which is 5. Fine. So sine alpha, h sine alpha is 3 over 5 h plus 5g cos alpha. This is 5g times what? 4 over 5. Okay, so the normal contact force R is 3 over 5 h plus what? 4g, that much Newton. Okay, so we got the normal contact force. Okay, fine. Now let's consider a very important concept. We need to find out the smallest possible value of h. Okay, now consider when h will be the smallest. Okay, h has a horizontal component along that way, right? Horizontal component along the up the plane. That means h will be smallest when the friction will also be acting in the upward direction. Because if friction is acting in the upward direction, then the system has to be in equilibrium. The system has to be in equilibrium. That means the friction and the force H will have to what? Balance out the weight. Okay. So if you consider like why the H will be the smallest, because if the friction acts upward, I said what? When friction acts upward, the force H will be minimum, because the equation will go like this: H plus the friction will have to balance out the weight, the horizontal component of weight, obviously. I'm just writing it for the understanding. So if you get H, if you make H the subject, you will get W, weight, minus the friction. So that means some, like uh, since the system has to be in equilibrium, the friction will take out some part of the weight to make it balanced. Okay, that's why H will be the least, and it will happen, the least value of H will happen when the system is in limiting equilibrium. Okay, because in limiting equilibrium, the friction, the particle P will be on the point of moving what? Up or down the plane, because we are considering friction acting up the plane. So uh, when the particle P will be in limiting equilibrium and on the point of moving down the plane, friction will act upward, and at that moment H will be what? Minimum. Okay, so let's find out the maximum friction. Since limiting equilibrium, so we need the maximum friction. F max equals to what? Mu R. So the value for mu it's given, right? Mu is what? 1 over 4. So 1 over 4 times 3 over 5 h plus 4g, that much Newton. Fine. Now we need to resolve the forces. We need to consider the forces along the inclined plane. So up the plane, what? The horizontal component of h is acting, which is h cos alpha, and friction is acting F max up the plane, because we are considering h is the minimum, so friction must act upward, up the plane. This is equals to the horizontal component of weight, which is 5g sine alpha. Okay, so cos alpha is how much? 4 over 5. 4 over 5 h plus 1 over 4 times 3 over 5 h mu r, that one. 1 over 4 times 3 over 5, this is basically 3 over 20 h plus what? 4 4 cancels out, just g. This is equals to 5g sine alpha, so 5g times 3 over 5. So we need the value for h, isn't it? So h, take h common. If you take h common, then what you will get? 5g times 3 over 5, that is 3g minus g, divide what? Divide 4 over 5. 4 over 5 plus 3 over 20. This is basically what? 19 over 20. So the least possible value for h would be how much? 2 times 9.8 over 19 over 20. This is basically 392 over 19, which can be written as, they wanted the value, isn't it? The smallest possible value of h, which is 20.6. 20.6. So least possible value of h is what? H. So h least, it is what? 20.6 up to 3 significant figures. That's it. And that's what exactly question in part 6a has asked for. Okay. Next is part B. So the horizontal force is now removed. Okay, the horizontal force H, it is removed now, and P starts to slide down the slope. Okay, so now particle P, as the horizontal force H is removed, it has resultant force in the downward direction, so it will be now sliding down the slope. In the first t seconds after P is released from rest, P slides 1.5 meter down the slope. Okay, so the particle P is has slide has slided 1.5 meter down the slope in t seconds. Fine. Now part B asks to find the value of that t. Okay. So after the force H, but the horizontal force has been removed, you need to consider like what it will impact on. Look, the force H has both the horizontal component, that is along the plane, inclined plane, and also has the vertical component. So that means since it had a vertical component, so definitely as the force H is removed, it will impact the normal contact force. So if normal contact force is impacted, then definitely it will have an effect on the friction, because friction is mu r. So right at first we need to find out the what? Normal contact force R. Okay, so consider the forces perpendicular to the plane. In that case, H is removed, so R will be equals to what? 5g cos alpha. So cos alpha is what? Cos alpha was 10 alpha was 3 over 4. Cos alpha is what? 4 over 5. If I'm not wrong, I'll check it. 4g Newton. Let's have a check. The cos alpha was 4 over 5. Okay, that's fine. Correct. So now we need to find out the friction. Now wait. Friction, will it be maximum or it will be anything other than that? Definitely it will be maximum because the particle is in motion. Friction force is maximum when a particle is in motion and when it is in limiting equilibrium. Okay, so we need to find out the maximum friction F max, that is equals to what? Mu r. This is the new friction because after the H has been removed, the contact force has changed, that is decreased, and therefore the new friction maximum friction force would be just G Newton. Okay, this is basically the friction force. The value for mu, isn't it 1 over 4? Okay, yeah, perfect. This is G Newton, the maximum friction force. Okay, now consider the forces along along the inclined plane. So since the resultant force is in the downward direction, not the resultant force, the particle is accelerating down the plane, so take down the plane as positive. Okay, you can take the other way around, no problem, but better to take downward as positive since it is accelerating, so makes it keeps it coherent. Okay, so uh, in the downward direction down the plane, the weight component is acting 5g sine alpha minus the friction is g. This is equal what? Ma, mass is 5 times a. Fine. Okay, now sine alpha is what? 3 over 5, so 5g times 3 over 5 minus g equals to 5a. Now from there, what would be the acceleration? So a would be 5g, that is 3g minus g, which is 2g over 5, which is 2 over 5 g meter per second square. Fine. Okay, so we got the acceleration. Now we need to find out the value for t. The distance traveled is how much? 1.5 meter along the inclined plane, isn't it? So we know the distance. Okay, we know the acceleration and we know the initial speed. Initial speed was 0 meter per second, isn't it? Distance traveled is 1.5 meter and acceleration we know here. Okay, so we can easily find out the value for t using which formula? You can use s equals to ut plus half at squared. S equals to ut plus half of what? At squared. So half of at squared, half of acceleration is 2 over 5g times capital T squared. This is equals to what? 1.5 is 3 over 2. Okay, so make t the subject. So if you write t squared would be what? 3 over, okay, 2 to cancels, so 1 over 5. So 5 times t, which is 15 over 2g. So the value for t would be square root of 15 over 2, 15 over 2 times 9.8, isn't it? 15 over 2 times 9.8 whole square root. Okay, so that would give you 7 square root of 6 over 2. Okay, the value of t is that's it. And if you write it to three significant figures, it will be 8.57 up to three significant figures. So we got the value for t, the time to descend 1.5 meter. This is basically 8.57. Yeah, they wanted the value of t, so the unit doesn't matter. And that's all about question number 6 from M1 October 2024 paper.